Hello everyone, we're back, and I'm going to do a quick sound check to make sure that everything's correct and working as usual. Okay, so we're back, and for today, hopefully, we will be able to address some of the other issues we had with DirectX 12 earlier, and some of those issues are easy to fix, some of them are not, so we'll just continue with them today. First of all, I just updated my Visual Studio, so gotta run a generate script to regenerate somewhat the resources that we missed from earlier. And since it's not increasing for the full screen, we'll just do it this way. So just gonna generate with BS 2026 to regenerate those. We'll see what happens. Alright, we're golden, so we can just run that. So from last day, we were working on getting our DirectX 12 implementation somewhat working, and for people join us on our new adventure, we are trying to convert this procedural triangle sample to work with DirectX 12, and we'll just set that at the start of project, and I'll just give it a run just to see what it looks like, or just to show you what it looks like. it's a simple program that it's a simple render graph that creates an off-screen texture right here. So it creates an off-screen texture here through the render graph, and fortunately we don't actually use the depth stencil at this point in time, so we can effectively get rid of it, and it's really just the off-screen texture. And in fact, I will just get rid of it right here. So we create an off-screen texture, and then if you're wondering why it's copy destinations, because it has to clear the image so that the texture itself will be in copy destination once it's created. That's why. And then we don't need to clear a depth sort of thing. So when we execute the off-screen pass, we simply clear the render target to some color that we want. In this case, black. And right over here, it looks like we're having cannot read texture because it was not imported. Okay, so maybe it's I didn't complete the change yet. So we're reading the texture, and I'm sure it's this one right here, but let's see. I hope we don't read the depth texture anywhere else, though. Let's pull out our Git client called forks. Okay, so what did I delete just now? The depth stencil. Right here. It's reading this texture, but this texture doesn't exist anymore, and we don't even need it either anyway. So it doesn't even need to be there, and we can get rid of the depth texture listed here as well. And I think this should be good. So this is the program that we're trying to use as our test application to get DirectX 12 working on in the engine. All right. So I'm just gonna put this over here in the corner. Looks like this is running DirectX 12. Is it? Can't really tell. Oh, it is Vulkan. Oh, right. So what's happening is that the shader compiler, I guess, needs to be compiled separately. Otherwise, it doesn't work. So we'll just compile the SPERV shader compiler. Looks like it's compiled already. So why did nothing happen? Oh, right. Yes. Okay, I see why. I was trying to show something. Okay, well, let's undo that. And we should be able to run it this time around. What is this error? Failed to read shaders. So what happened? Yeah, it didn't read the shader, and I know why. Again, yes. Shader compiler right here. There's no shader compiler configured for this sort of thing, so that will cause an error. And I think that should be hopefully the last of the things that we disabled. So we're trying to run this test application that compiles a relatively simple shader. And what that shader does is it displays this triangle here. And yeah, it's a pretty simple program. I can make that full screen, or I can just close it. See, no issues with Vulkan. But we can't necessarily run the sample in DirectX 12 yet, and that is something that we want to fix, or we want to implement over the coming live stream. And I think I'm just gonna undo all the things that we commented out. There we go. Keep them disabled. And then we can specify some run arguments here for what kind of renderer we want to use. And I'm just going to switch over to D3D12. And then if we try that, we'll see what happens. And here we are. This is what we are faced with in DirectX 12. We literally just have a simple window here. Yeah, that really does nothing at the moment. And let's see, get this back up here. Yeah, so this is what we're working with, and we actually got it to this stage from last stream. And what we need to implement now is, well, first of all, we need a swap chain back buffer, which we don't have currently. So that's what I will work on right now. And before I do that, let me just commit the fixes that I did for the query pool. I'm also going to remove this depth texture from this because we don't need it anymore. Right, so here we are. I'm thinking I should probably add a monitor argument so that I can pass in a monitor to this right here, because that would make things probably a lot better to specify which monitor we should actually create the window in, rather than having this still here. And we can do that because we have we do have command line arguments, argument types. I'm just trying to see command line option. There we go. So we have different types of command line options, and I'm looking for integer. Yeah, so you literally just create a static variable, and then you specify the name and a few other parameters as well. But what I'm gonna do is I'm just gonna copy something like that and paste that in here. And what header is this? Utilities. Okay, so window, the window where the monitor. Ah, yes, not the window number. Up, monitor ID. The monitor to launch. Launch the application window, and I think that's just the default ID or the default value. That's going to be 0. Yeah, so we'll have that, and then we can now pass in the monitor ID, which would be monitor 1 here. Oh, okay. And then all we have to do is literally just read the value, if I recall. There's not much else we have to do, if I recall. We just read the value as is, yeah. Yeah, so we just read that value, and then we should be able to specify the monitor ID where the stuff should display in, and that would be option monitor ID get value. Okay, and then we need to specify a log thing. Yeah, there we go. So that way I can actually commit this change rather than fixing a default value for what monitor should display in. And then if we run that, let's see what we get. Yeah, it works. And I'm not sure how I can actually show you what the value of this option is. But if we change this to always, let's see what happens here. Oh, right, it's right here in the top. I didn't see that. Yeah, so you can see it's actually set to 1, which is what we want. And yeah, that gives us the flexibility of passing an actual window number that we want the application to launch in by default. And I'm going to leave it back to always if specified and just double check real quick to make sure that we can still see it from the top here. So we just go, yeah, we can still see it right here. So that makes it a little bit easier for us to work with anyway, right? So alright, so we can close that, and we're going to commit that as well. So that's just worth a reason to have that in the sample, and we may likely promote this feature to the game application, right? So awesome stuff. just come here and make that. There we go. Might as well format the. Okay, it's formatted. And this was, we added monitor command line option. Okay. There we go. So that's always nice to have. All right. So what else is next? Like I said before, we wanted to implement swap chain back buffer, or a way to retrieve the swap chain back buffer in DirectX 12 mode. So that's in device, swap chain, and that should be create back buffer internal. Right now it does nothing, but obviously we want this to do something. And if we go to texture, why? All right, so let's see here. This looks a little bit more sane, but at the end of the day, it's still not good enough for what we want to do. And there should be a way for us to have a native resource. Native. Yeah, so if it's a native object wrapper, then we don't need to do anything. Yeah, you know what? Let's just try creating a back buffer texture first, and then we'll see what happens. I mean, hopefully it's not that bad. But if it is, then obviously we'll have to figure out how we'll handle it. So from the swap chain, we can do something like this, where this index here is the current back buffer index. And we will have to synchronize this somehow, right? So we can come here. So we've got this thing going on here. Okay, so we would want to do reserve the buffer count, because that's the number of textures that we'll have, and then we'll just go for okay. So we retrieve the resource. I mean, we don't need to initialize this to null pointer, but We get the one from 0, cast it to a nice D3D12 resource, and if it failed, then fail to retrieve the back buffer resource from the swap chain. And obviously this is a fatal error. Okay, otherwise we have the back buffer. This is not how this works. So yeah, this is just not how it works. Yeah, nah. So yeah, this is just not how it works. So we'll just get rid of that. So right here, at this point in time, we now have the actual D3D12 back buffer, but we do need to do some management internally, which is where this comes in. So we'll need to create a GAL resource, or a graphic abstraction layer resource, and this is with texture creation description, and we're just gonna leave it that way. So back buffer resource, back buffer type, and in fact, I'm actually just gonna copy the struct from the Vulkan swap chain right here. This is basically everything, and we just paste that right here. And right here for the existing native object, we just simply give it, we just give it the texture p back buffer resource, and we can delete that, and same thing again. And I'm actually gonna set count, I guess. Set count. So that way we have that, and then we can do this. And you know what? I'm actually gonna call it swap chain textures. I think this is even better. There's a better name to call it rather than this. Swap chain textures. There we go. Yeah, I'm just gonna call it swap chain textures from now on, not back buffer textures. We just do that, and we can come back here and pdevice d3d12. Oh, we don't have access to the device. Well, I guess what we'll do is and I think we don't pass this in here as well, yeah. So hit pointer zero device D3D12. There we go. And from then on, we can say p device D3D12, create texture, pass in the texture description, and what else do we need from this? Set the name, and yeah. And string builder stays outside of that. There we go. Perfect. So this is where we create the actual back buffer texture. What else do we need from this? I guess we can just return from here. Yeah, I think this should be correct. Technically, we can possibly retrieve this from the actual texture, but we don't do that. Okay, so that should actually create internal back buffer texture. So what remains is, obviously we want to be able to destroy those textures, and there isn't one? Yeah, we just clear it. We don't necessarily need to do a lot of work. But I still wanted to carry the same semantics as Falcon. So let's just make sure. So we have this function here that releases swap chain resources. Alright, we needed semaphore management for this, but I don't think we need that in... I mean, we probably do, but... So in the update swap chain, and right here we also want to use dynamic cast. And we want to dynamic cast that. By the way, this is not the C++ dynamic cast. It just uses our own runtime type information system, or RTI or RTTI system, to cast the object to the descendant pointer. So it will devolve to static cast, but then it will check if it's an instance of the actual object itself. So you can take a little look at that comment up there. But yeah. There's probably some work we have to do here to resize the buffer. You know what? I think this is probably fine. Yeah, I don't think we need to do much else for this. Although, we actually do something here called lock command queue and run. To lock the command queue and run a specific sort of command. I'm not sure if this is any good because yeah. Not actually sure how helpful that is because wait a second. Okay, submit happens under a lock. You know what? We'll just run it without the lock if we run it into any issues, and I guess we really need one for D3D12. But I don't think it's gonna be much of a problem right now because this is the Vulkan swap chain. Ideally, we want to lock the command queue for this one so that we create this sort of thing. But I don't think it's absolutely necessary for DirectX 12 specifically. Possibly it's needed for DirectX 11, but I don't think this is necessary for DirectX 12. So I think we'll just leave it that way, and then we'll just try running it again to see whether or not it actually creates the resources as advertised. If it crashes, well, we know that texture implementation is wrong, or at least needs some work. Okay, so we've got that part done, and then I'm gonna close that, and I think we're still running DirectX 12, yes. So what we can now do is enable, or actually, there's another sample that I have that does something a little bit different. With the off-screen path. So it clears things a little bit different. And we can try that here, if I can find it. Here we go. And I'm just going to put that into the procedural triangle. And I'm going to run that in here. So instead of clearing it to black, what I'm going to do is I'm going to clear it to a plethora of colors, so it's going to be flexible in that regard. Yeah, so let's see, we should be getting an animated clear screen right now, because it does call clear. Oh. Well. know, one thing that just occurred to me, I think the render graph is stalled. I don't think the passes that we're expecting to run in the render graph are running. So what we can do is when we're setting up a path, we can actually force it never to be called. Actually, you know what? There's two things we can do. We can come to the top here and we can disable culling for the render graph. So in the render graph compilation, we can simply turn off culling. Yeah, we can disable culling from the render graph itself, and that way no path gets culled. And let's try that and see what happens. Because I think the clear path is getting culled. Oh, it's not. Okay. Okay, well, let's check it out. The execute should be running something if it's, yeah, it's not running. That's what I meant. It's definitely getting called still. Or something else is happening. Let's see, because this runs every frame. Still nothing. So if we go to this portion of things and do this, nothing. Okay, now it works. Here, okay, so go over. Can render is false because swap chain, let's see, what is the current size? It's 960 by 540. Oh, the back buffer is still, oh, right. Yeah, the back buffer is still null. Right. So we gotta fix that. I think we start at 0. I'm not sure how we actually rotate the current back buffer, but I think we just set it to 0. So I just pulled the DirectX sort of documentation here, and it really just tells us that we can simply have a back buffer index that we increment every time we render something, and then just do a fallback of sorts, which it's not a bad idea. And I'm just going to zoom in real quick, 150%. But anyway, it's really just saying that this is how we would switch through the textures. We have an integer index that starts at 0, and every time we call present, we just simply cycle what the current back buffer or what the current swap chain image is. And I think I've done something like this in the past. So if I go to GitHub in a moment and go to so we released a graphics sample at one point in time. So right here, we did release a graphics sample 2 years ago. And that graphic sample was, we did have a D3D11 sort of swap chain here, and things are similar. Obviously there was a bit more, it's a little bit more involved to clear, to resize buffers in DirectX 11, and this was using the deferred context. But if we just take a look here, so create back buffer, blah blah blah, and then we go all the way down here. Destroy back buffer slash object. Okay, so right here we retrieve swap chain, create the actual native objects. We check the color formats. If I recall, yes, we could not create an sRGB back buffer. We had to create an off-screen texture and then copy to it in D3D11 with deferred context, or using the flip discard or flip. Yeah, I think it was flip discard. Yeah, I think it was flip discard rendering mode. So I don't see where we're actually switching the back buffer. And yeah, like I said, we had to copy to it before submission, which was a little bit inconvenient, but it worked, and we didn't really have any issues with that. So present, and it doesn't even give us an actual, I don't think, it looks like we didn't even have a way to cycle through, the current frame buffer as well. So that is probably something that we'll need to take a look at. So, I mean, what I'm thinking is right now we just have an integer, and we just cycle through it every time we present. Now that is a little bit, I think it's good enough, but I'm just trying to think if I may need to add something else to that, whether or not that would be okay to proceed with. Yeah, I guess we'll just proceed with that. It should be, I mean, if we need to expand that option, we'll probably do that. But anyway, we just come here, just add something here, and then proceed. I will just do that for the current back buffer index. And every time we call present, or after a successful present, then we just simply do what the docs was telling us to do earlier. And so we just do this sort of logic here. And that is after present. So this would be and this would be +1. Oh, and this would be description. Swap chain textures. Yeah, I think we just do that. And I think that should be fine. And then also we need to update the current back buffer. And I think that's what we're missing after creating the back buffer texture, which makes the render graph not run. So right here, we need to set so this needs to be set there. So this will be returned by the interface in the swap chain header. So if we do this now and see what happens, we should get a render or a can render true now. Perfect. So it's true. And I think one thing we need to disable is GPU profiling. Because I'm not so confident in that query implementation that I showed you guys the other time. And yes, error. Create place resource has an issue. When creating a texture. Okay, well, let's commit this change first. Okay, so now we need to refactor this whole texture thing. And I'm not sure why it's trying to create a place resource. Like I said, this should not be happening. Yeah, this should not be happening at all. Like, yeah, no. I wish there was a way. Is there a way, because most of this will have to go. Well, let's double check what the error was. And actually, let me see if okay. So P3. Okay, so actually, let's go to device D3D12, and then let's see. Apparently, in the in this info queue, we can register callbacks. Um. Okay, so it looks like it's not going to be as trivial to actually log the messages directly to our terminal, because I was thinking maybe if I could log it to this terminal interface here, but I can't, because essentially what I'll have to do is I think is to pull all of this or get the number of messages, this one I believe, and then somehow get, because we can add messages apparently, so it would be to use that to somehow get message. Where's the message? Yeah, so it doesn't really work the same way as Falcon does, at least. Okay, so what will we do now? Well, I guess there's not much else we can do, but the error is right here. It says invalid combination of state bits. But the thing is, like, we're not. Oh, wait, yes, we are. Okay. Yes, we are creating an image. And in fact, what I'm gonna do is I'm gonna let it break point once more. And I just wanna see what sort of state we're passing to this sort of thing here. So create resource, and what is the state? 273. Undefined, somehow that is a state. That's new. Okay, the resource, render target. Yeah, just say the resource and render target. So what is the thing here? I think I see what the issue might be here. So we're creating in both common and one of the other states. I think that's it. I think that might be it. But this should be 0 though. And the thing is, we're creating the state here rather than doing it earlier on so that we can see what state it's actually passing to the... Yeah, we'll just do it here instead. And this would be D3D12 resource state. And then we will replace this with now let's see what happens. So just right here we can see, oh, this is even worse. This doesn't even give us anything at all. Why is the undefined state marked here? If we go to the enumeration for resource state, oh, but when we convert this to a resource state, it should really only be like this should be 0, which is basically resource state common. And then what else do we have in this sort of thing? We have shader resource, render target. Shader resource and render target. And it says it's an invalid combination of state bits. Yeah, so it's still not immediately obvious what we're dealing with here. Yeah, I'm not sure what's invalid about the combination that we gave, but oh, is it this? But this should be correct though. It's just render target, and where's the render target sort of thing here? Right here. So we want a state in render target and one more in shader resource. Okay, well, let's see. Yeah, I'm pretty sure this is correct. So I'm not sure what's invalid about it. Yeah, so I'm not sure if this is actually coming from our initial flag, but it looks like it is. That allocation looks a little sus, but anyway. Wait a second. Wait a second. Resource description. Okay, so I think what we'll do is this seems to be similar to the other issues that we've had in the past where we had to just go and use common state. So I guess what we'll do is we'll just simply remove I think what we'll do is just remove the initial state here and just create it in common state and call it a day, because this is not going to help. If we want to tighten up the creation, we might, but right now this is just not gonna work. So we will just create it in common states and yeah, make life easy and not have to deal with all of that. So we'll just make it in common, and then we will update the API to not have this sort of thing in there anymore. And the texture thing needs to be rewritten, I think, because it doesn't look great to me. So, creation state can go, and yeah. So let's try that again and see what happens. Whoa, okay, that worked. And we've got new, okay, well, we've got some errors. Error. State undefined. Render target. Shader resource is invalid. Undefined cannot be combined with any other state. Yes. So let me do this real quick. So where's undefined coming from? Right here. Who else is specifying undefined state? So maybe for the sparse one, we will. Yeah, for the sparse one, I think we will stick with this. And where is it? This is a little messy. Not that. Alright, so this is our initialization right here. So if there's an existing native object, we will set the state actually to just render target and call it a day. Otherwise, blah blah blah, could not. Yeah, so this is I want to have this as similar to what we had for the buffer, that this cannot be created currently. Yeah. And I think and then we'll just return failure here. So, okay. Where else do we set resource state? And where's the sparse memory, last texture? Okay. Tempted to just get rid of this, frankly. But anyway, yeah. From bind flags. Who binds on the find? Like, okay, I'm just gonna delete this. Might as well clean it up now. So this doesn't need to be there. And we're creating an allocation. And actually, you know what? We actually should start with path. With path, we don't create get texture plus final size. What is this? Ugh, this is not needed anymore. Delete. And this should be gone. Not sure what the null pointer here is for. I think it's for the initial, for the clears, which we don't need anymore. But anyway, let's mimic what we have for our buffers. I'm gonna put the buffer on the side here, and I'm gonna reduce the zoom to 150. Hopefully you can still see it. Hopefully, but it's only gonna be for a moment, so it's probably fine. Alright, so the right on init platform, we have external memory description, which is a member of that. Yeah, I don't think this needs to be here. But anyway, we'll start with that as usual, and then we'll just leave these error logs. And obviously, if we have like an existing native object, it will not run the rest of this. So we're good there. And then we will just simply so we need to ideally we should have filled this right here, but you know what, it's probably fine. Anyway, so we'll have external memory. Actually, you know what? Maybe we should fill it up here. Right? Because what we do have is this build texture resource description, which is called for every branch, but does practically the same thing. So we can inline that and not have this into a function. And I think it looks generic enough. So we'll just come here and put it in here as well. And this should be description now. And now that we have that, we will set the external memory kind none, and with that we can now check if it's a sparse thing here. this should only be like this should be close to, because this doesn't really contain much. If you open it up, it's really local information, so this doesn't need to be here, and we will move that away from there as well. But it's really messy right now, and hopefully we'll be able to clean this up and put it into something that's a little bit more enticing. Anyway, so back here, we are doing all of this to get things. Yeah, that's good enough. And we will do the same thing here, where we check first if it's a sparse resource. Then we can, hold on, what is this? Oh, right, yeah, so if it's equal to, and then obviously if this is the case, and we can actually just copy the one in here. Yeah, we can just copy all of this actually, and just put that in here. There we go. And then we don't need this. We just need that. And I'm not really a fan of calling IID. So what I'm going to do is I'm just going to copy the one from the buffer. Oh, okay, buffer does it this way as well. Yeah, you know what? It's probably fine. Whatever. Yeah. So we'll just leave it with this sort of thing. And what is this error here? Resource state, which we should not be having. Oh, right. Okay, so we still need a resource state here, I think. So this, I don't know, this can be just null. Yeah, it can just be common. Yeah, I don't think we need anything else other than common. So we will create that with common state. And one thing though is the texture description we have actually contains like an optimized clear value, I think. Yeah, right here, which can be passed in at creation time, which we will likely just use here. Yeah, so clear value dot format, and then oh wait, that's not what I meant. I meant clear value format, and what is this? What else is in there? Color. This should be color. You know what? I'm just gonna move this over here and probably just copy this one. I mean, it would be nice to have a converter of sorts that did this rather than having to do it in line here. But yeah, this is really nice, I think. Yeah, so we can probably move this to our utilities. That way, and I don't think optimize clear value contains, yeah, it's all copyable. Yeah, so, and 20 bytes, which is pretty small. And we can just go, okay. So we'll just create a converter here. Static, that. Yeah, so yeah, so there should be that, and copy that. Always in line, and yeah, and then we can just copy this from here because this is a proper implementation of the optimized clear value conversion. So we'll just start with this right here, and then we will simply copy the rest of this, and then we will return the optimized clear value. Oh, right. This should be clear value resource format. And this should be a dot operator. Why is this giving us error? I think it's still used in the old. I think if we format the code, it will pick it up. Yeah, I think we'll do it this way. Okay, yeah, it's well, just build that just to see. It will have errors, but just wanted to see. Texture utilities is not a class or a namespace name. Now, what that tells me is the PCH or the precompiled header does not include texture utilities. So it should include texture utilities before this. So if we do that, then obviously it should now have texture utilities before that, which should fix that issue. And double check, yeah, it fixed it, voila. And I'm just gonna format the code here. There we go. Fantastic. And I can close this now. Yeah. Okay, perfect. And we don't even need to call this optimize. Okay, yeah, we'll call it that. All right, so RGBA, we can probably just mem copy, but yeah. Like the layout is tight enough that we could have just copied or did a little mem copy over there to this sort of thing, but might as well be explicit. Okay, so now this function here will use get clear value, and this should be p optimize clear value. We'll dereference it so we can get the reference, and then we'll store that in optimize clear value, and we don't need that there anymore. D3D12. Why is this giving us an error? All right, of course. Okay, so perfect. So that should be the new scheme of things. There we go. So that simplifies that code. And now we can reuse that sort of thing here as well, where we just simply create, we just do this. CD3D. Yeah, so this should just be clear value, nothing else. And now we can pass that clear value to the resource state here. Instead of null, would be the clear value. And then we set the state to undefined. And then we fill fast texture properties, which I think is fine in my opinion. Like, this is okay. Yeah, this is okay. And then we return success. So clean, I think, or subjective, but that's reasonably better than what it was before. And then if we go to the buffer, we can check it out here to see, well, same semantics really. We don't have, so else, so if it's immutable, default, dynamic, or whatever else, then we will create the regular textures. And then if it's staging, then we will create a buffer instead. And then we can do a buffer to image copy, which should be easier than whatever it is. All right, so we'll go else if description the usage equal immutable or dynamic. Actually, you know what? Immutable, mutable, or dynamic. Then we will do whatever we need to do. Else if staging, then we'll do whatever else we need to do. Else, we will just simply do that. Yeah. Else we will return success at the bottom over there. So I don't think we need this still, do we? We probably still do. Right. So I think I can just copy this and just have that at the top of every one here. So this is part of the texture resource itself. Why is this here? Well, that's interesting. It looks like we store a description for textures, and then we store. Oh, right. I think I know why. Yeah. Okay, that makes sense. Never mind. Yeah, I think that makes sense. Buffer, Vulkan, sharing mode. Oh, okay. It looks like, is it not implemented? It's not? Oh, right. I don't think it's implemented for buffers in general. It's really for textures at the moment. Okay, well, you know what? That's perfectly fine. I'm just gonna close. Yeah, I'll just leave them open for now. And um, texture. Okay. So we can't just copy this over, is what I'm seeing. And then we can delete this from here. Build texture description. Build staging description. I think we already inlined this, so we can get rid of that. Um, the nice thing is that it's a single um, the nice thing is that it's a single resource description. So when we get to staging, we can literally just change the dimension and then the rest of the things that need to be changed and call it a day. Right. Okay, so okay. So okay, all right. So what we'll do is um we'll just simply check the external memory kind here, and if it's importing external memory into D3D12 textures not currently implemented, we'll just copy that and put it across here. And what is this? Yeah, we don't even need to do this. Um, import it or export it. Um, oh, okay. I guess we would need, well, we would want this to be here in the top as well, like this. The allocation info and then the external memory type. Or we could just put that on separate lines actually. Okay, so I guess we can do this instead, and then undo, and then put this back in here. And that way we can export it, but we can't import it yet. Exporting is, I think, easier. And we can do that across the board. I think for staging resources as well. Yeah, so I think we can do it for both. Um, and then we can get rid of this from here. And then all we need to do is switch on the usage in here. And then report what heap type to use. So right through here, we would have a switch. And then obviously if it's these two, we would have this one. And I'm actually just gonna break outside. And we can do that for the rest of it. So we have dynamic remaining really. Dynamic, the full case not, oh, because this already checks that it's immutable or that, so I don't even think we need a default case anyway, but we're just gonna put that in there. So this is heap type default. What heap type are we actually using though? Yeah, so the heap type should be, you know what? We actually don't even need this if that's the case. Yeah, we don't even need this at all. And it can come after. And if we have a default heap, um, so switching usage, if it's default, do whatever we need to do to create that. And I guess we can actually, you know what? We can just do this and actually create our texture. And then obviously we can, and I'm gonna move this to the side for now. And I'm gonna put this back at 200 zoom. Okay. Actually, we can close all of this now. Close other tabs. Then you can open up the buffer here. Okay. So we have this sort of thing here. And with that, we can actually create our texture. And then if has initial data, we would need to do something here. And okay, final state doesn't exist, so let's just put that in there for now. So if it has initial data, we need to do something. Heap flags. You know what we can do is for the heap flags, if we have so what I'm trying, let me actually discuss this a little bit. So we actually do have a flag here to create, we can create a texture without zeroing the memory. So if it's needed for whatever reason to create a texture without initializing the memory heap, without zeroing the memory, I guess we can allow that. And that way, I think there's a create zeros as well somewhere where there should be, or just none. Okay, well, I guess. Yeah. Okay. Well, I guess. Okay. Well. So if we have if we wait, see here. Yeah, so if we have some initial data, then we don't need to zero the memory because we'll override it anyway with some work, right? So this should be allocation, create info, heap flag, create not zero. Yeah. Yeah. So we can avoid. Yeah, so we can avoid the zero initialization of the entire resource. And then yeah. And we can probably put this for every other resource as well. You know what? I think buffers, we potentially not initialize a buffer. I'll consider that, but I mean, I don't know if we do that currently. Yeah, I don't think we do that right now. But I guess we can possibly do that if it's a valid flag. Um, yeah, I think we can probably do that if it's a valid flag, but I don't know if it's a valid flag. Let me just double check real quick. So, yeah, so we can do the same thing for buffer. where if we are going to write something to it anyway, and in fact, let's see. So where we create our buffer and the allocation info, we can do so right here and say allocation info or allocation info. You know what? If we, okay, there we go. If there's initial data, we need to ensure that the buffer is created in memory heap that allows, this is because, no, this is not what I wanted. Heap flag create not and I think I like the comment here. Okay. Yeah, I think this is okay. Yeah, whatever. This is okay as a comment. But essentially we're just trying to save some yeah, so yeah. But the only thing is, if we're writing to the buffer and we're not writing the entire, well, I guess we'll just have to initialize the entire buffer itself. We'll supply data that is as large as the buffer itself and not just variable size initial data, right? I think that'd probably be the best resolve. But anyway, okay, alright, there we go. So we've got all of this set up. And one of the biggest things now that we've got to do is we've got to fix this thing called upload initial data with command list. This thing is not that great. And I'm just going to do a quick sound check here. So just give me a moment. Okay. So this whole thing is not that great and needs to be gone. Like, look at this. No. No, 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 no. No, 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 no. Not a fan of this at all. And if I were to pull up our fork instance here, did we commit some of these things? I think we probably should. This one's an easy one to, because we basically moved it to type conversion and we used it for the texture as well, wherever that is. Well, you know what? That's okay. Buffer. Yeah, so. Alright, and then right here we removed initial data, initial state from texture. So create image with resource state common. And then here we optimize the buffer thing, and the texture is still getting work, getting work done. So we'll just put that in here as its own commit. Optimize. There's initial data. If there is an initial if, I'm just gonna leave it as if initial data upload. Yeah, so we'll just do that. And then we can so this is just part of the big texture refactor. All right, so how do we even do this in the Vulkan texture? Vulkan texture is a bit complex. It's very, very complex. But similarly, we have this upload staging data thing that does the actual data upload. And then all we need to do is just, again, have this sort of thing here. Oh, this is still using dynamic cast, static cast. So this should be a Vulkan command list. Yeah. So use dynamic cast. So we have, again, this scheme. And I'm just going to come here and right here, we have, I think this is correct. Initialize image contents. Where is this called? Yes. And we'll call that in here. And then all we need is just this signature here that we will and this should be D3D12. I'm not sure if we should succeed or return. I'm just gonna leave it like this. Yeah, I'm just gonna leave it that way. But I did see that we did return a result for this one. And I'm thinking, you know what? Just to keep it similar, we will just return the result. That way we can have that there, and then we can return success here, and then we can succeed or return on this. Why is this giving us errors? Okay. And then we can have this here. Okay, so here we are, and so now we just got to figure out how to upload things to the buffer itself. And initially, what we came up with was to have right up here was to have this little piece of code here, and this is what we were using to initialize the staging text, to initialize the texture, and in Vulkan, what we do is we actually suballocate the buffer and then copy that buffer to the actual texture using a buffer to image copy. That's how we did it in Vulkan, and I'm assuming that we would likely need to do the same thing for this sort of thing. Now, it's not immediately obvious how we'll go about this. Like, this fluff is the main thing, and that's what we're mirroring here. So how did this even used to work? We had this thing called on the texture. Okay. We can actually delete, okay, what is this even? Okay, so this is the actual upload. Placed resource. Why is this using, it should not be using that at all, but we'll just ignore that for now. We have the buffer description, so we create a buffer of sorts, and we do all this management for the buffer, the fence, and all that sort of thing, which is really not needed in my opinion, because we having to do all that work to create and manage a buffer. That is not it. So what we'll do is we will come back to our thing here, and we will notice that we can simplify this process by a lot. So generally, all we need to do is just create the buffer, map it, and then do this loop and upload it and copy it to the texture using this copy region thing. And I think that's all we need, and I think it should handle the resource barrier, if I recall. But you know what? I don't know. We'll see. So first thing, let's come here and begin with the initial mapping. And right now we do have initial data, and I don't think it's a data size. I think it's a sub resource, the get count. Okay, so here's another problem. We don't know how much we need to allocate. Compared to a buffer, we have no idea. So we can't just, as far as I know, just initialize it with the full size. So what we'll need to do is we'll likely need to follow this method here where we do it for specific bit levels and etc. Okay, so let's see. Initialize image content. So we need this thing to get the actual like logical size, storage size, and then we allocate for the actual MIP size itself rather than the entire buffer. Okay, so perhaps we can actually mimic something similar here, and the upload buffer size is retrieved from this sort of thing. What is this? So we do the resource count. If count not equal to that, then initial data expected, blah blah blah, got blah blah blah. You know what? I'm actually just gonna copy this and just shove it into our new scheme here, and then we'll figure out the detail after. And I'm actually gonna delete this for now. So we'll start with this check, and this is with the initial data, and this is m description, the initial data. So we'll need to do this to get the sub resource count. Yeah, we'll just do that. And so when we have the sub resource count, we also need, what is this function that is too long? I think it's this one. We'll just minimize the other ones because yeah, so we'll minimize the other ones here. We care about this one that uploads to the command list. We can delete this, I guess. Delete this. Okay, so description, we get the description. We don't need that. Sub resource count, so we do this, and then we retrieve the placed footprints. Okay. So we will need to come here and perform the same action, and I think I can close this one. I can minimize this. I can minimize that. I can minimize that. And I can minimize, what is this? I can minimize this because it's fast resources, and I can minimize this port. I can minimize this. I can, and here we are. So right here, the thing is, we don't use the standard library for this sort of thing, so we'll use temporary array, and we will need this to be, it's already a pod thing, so we will just go to our PCH or our header, precompiled header, and add that as a pod type, and then we'll come here, and what we'll do is we will create one for the sub resource, and then we will set that place sub resource footprint, and then we'll just set that count there. And then we already have the buffer upload size, so we will just simply get the copyable. What is this destination description? Not sure what that is anymore, but let's take a look. I deleted it from the top somewhere, and oh, it was this? Destination texture. I guess we can retrieve that from this. Oh, whoa, 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 whoa. We're not doing it here anymore. It's down here. Okay, so we can do it here, I guess. And this would be MP-D3D12 texture, get description. Did we do it? No, we should do it this way. And that way, place resource footprint will receive our own get data. And then null pointer, null pointer. Well, hopefully this works. But next, what will we do? We will need to. What is next? We will need to. Well, remove this for starters. And then this becomes the upload data size, which now we can come here and yeah. So we can now come back and use this yeah, we can now use the upload size, and then we'll just issue a bunch of copies. Okay, I think that's okay. We did a little bit different in the D3D12 version, the Vulkan version. But this might turn out a little bit differently, but we'll see what happens. So we now have once again our allocation. And then this is simply, this is, is it a sub resource count? No, it's the upload buffer size. So yeah, it will be that. And this would be, so we don't just do this time around. So we need to do something a little bit more elaborate, which we have on the top here. So this is the mapping, and I'm just gonna get rid of the rest. But hold on a second. I think we need this. Yeah, so we do need this, and I'm just gonna copy all of this, and that is I think that would go here. So we will have the format properties, and actually this should, yeah, it will stay here, I suppose. It will stay here, and this would be description. And I don't think we call this function anywhere else yet, or I think we do. Oh, it's at the top yet. Never mind. All right. So here we go. So we will have this to retrieve the format properties, and texture description would be description, and this would be p initial data with a pointer axis. Mapped upload data would be This would be an offset of an offset, first of all. P-map memory. Are we supposed to add the offset to this? What? Let's see here. I think this is okay. But I don't think we should. Because if this is the right range, so I'm thinking we don't need to write the byte offset. Okay, so yeah, so okay. So we actually do need to add the byte offset, which I have not been doing. Right. So we should be doing this. This is buffer D3D12. So this should be this actually. And that is what we should be doing. I think that's it. And that's what we should be doing here as well. So we don't just, after we map the memory, we'll do this where we shift the offset, and then yeah, and then we can continue on with what mapped. Yeah, we don't need this static cast here. Like, get rid of this. So is this oh, never mind then. Okay, well, never mind. Okay, so yeah, no, we don't even need this. Why is this? I'm just gonna have this as a uint 8. We'll have that as a uint 8 instead. Hopefully that's better. Yeah, I think that should be okay. Whatever. I mean, hopefully it works. Hopefully it works. And I'm just gonna format the code real quick. I wish there was a way to put the formatter on the top bar here. Like over here in the top. I would like to have the formatter up here, but I'm still not seeing how to do that. So okay, so anyway, I mean the goal is to really get some clears working. So we just want to get rid of this and get it over with quickly so we can move on to other things. But anyway, we can do this, add the byte offset and then unmap the memory. And what we do at the top here is to also, and we can just delete all of this because it's just noise. And then we engage, we create a command list, and then we do a bunch of copies, which we can do, and then we issue a barrier, which we can do somewhere. Where can we do that? Well, we'll scroll down, and then we'll do it on the bottom here. Not there. And we can actually delete this now. We don't need this anymore. Delete. Okay, so right here, after we've unmapped the buffer, we can go for and copy texture. Now we can copy the buffer, and that would be okay. Okay. Key upload buffer. So we can't use the high level copy texture region because it's using the abstraction layer resources. So what we'll need to do generally is to move it to we'll need to implement some sort of copy buffer to image sort of thing here. And see if this in here. Yeah, I think we're doing a copy buffer region, or is it? Oh, it's a copy texture region. Source box. Well, okay, so, okay, well, let's take a look. Does this actually calculate the sub-resource index properly? Because one thing we could do is we could literally just continue on with it and just simply staging buff allocation, and then this would be the actual buffer, and then similarly for the texture it would just be the MP D3D12. Like it would be the actual texture, and this would be p command list D3D12 get D3D12 command list, or y. Okay, so I guess we need the graphics command list. Anyway, it will just be something to copy. Now, the issue with this is that if this is sub-allocated, we need to specify ranges, which can be wrong. Now, what we can do to alleviate that is to create a brand new buffer by specifying true on this. So be true here, which will create its own buffer for this sort of thing. And yeah, it will create its own buffer. Begin and end would be the size. Okay, so this should be the size here. then this would be 0 here, and then UI staging buffer. Yeah, this should be the size here, because we'll have the offset and then the actual size. And we just have the size here as well. And then we'll use staging buffer page size here as well. Yeah, so that way we can actually force it to give us a staging buffer that is hopefully big enough for what we need. Yeah, I think that should be it. So back to the texture. I mean, I would like to have this sort of thing here, but it appears that we don't necessarily need it. That we can actually just copy to we can just copy without needing any of that, which is obviously good, because then it decreases complexity to initialize texture of sorts. So yeah, yeah. Well, we'll see what we can do to actually implement this, but yeah. Anyway, I think this is going to be good enough. Okay, so okay, well, I guess we'll just stick with this. And and the reason why I'm not actually so sure if we need to specify what else do we even need to specify in this. So I think we may not even need to have an actual like dedicated buffer to this thing anyway. So I guess what I'll do is I'll just leave it as such and move on because we've got other things to do and we don't want to waste our time with that sort of thing. So that's where we'll leave it for now. And close command list, execute, request fence, wait fence. That is a bunch of things that we just don't want to manage and should now be managed by the command list itself. So simplicity for the win. So alright, so what is the next thing that we've got to do? I think I'll leave the fill sparse texture properties. I think this is, but the thing is, this function only gets called once. I mean, you could say that the Vulkan version does as well. Sparse texture. Yeah, so this also gets called once, but at least it's part of the object. This is a free floating thing. Oh, whoa, okay. Whoa, whoa, oops. Careful over there. Anyway, so this is its own thing. And yeah, I think I'm just gonna leave it there. It's fine. Anyway, so that should be the texture thing now done. And now we can just skim through and get the whole buffer thing done. So for this one, we can call it a day that we're done. And we can set the resource state to be, I think after this function is done, it's this one, and then it would be right here, set resource, set resource state, yeah, from bind flag. Yeah, it should be that, and I think it's the same thing for the staging texture as well. At the end of it, we'll have that. And what else do we need? We need readback or upload. Okay, so we'll just come here, put that in there, creation state, remove, remove, and resource description. We don't need. Okay, so what is different about? In fact, if we come back up here, the resource description is almost similar. I'd say we do this where. Wait a second. Resource description. Where does that? Yeah, so I guess what we can do is we can just take this. Yeah, we're just going to edit it we're not, yeah, just come here, edit, call it a day. So right inside of here, we will now edit the resource description, and actually we're gonna do it right here. After all the checks, we then edit the description, get staging texture data size. What is this? Oh, right. So description. So there we go. And then check that. And then we can actually allocate the text, the buffer that we'll need for the staging. And we can delete this now. Clean that up. We'll leave this sparse resource thing here. I mean, ideally we can move it into, you know what? We'll move it into the class, into the class function. And actually no, we'll just leave it here, whatever. Okay, so next thing we have initialize staging texture data, which does things a little bit differently. Because for starters, we need to create a buffer to do this. So this doesn't need to happen anymore. And then we can just copy this and paste that in here. And then if it has initial data, if it has readback data, cannot be initialized with CPU. Yeah. And then we just initialize the staging texture data, which we don't need to do from, actually, where's the buffer being created? Okay, right, alright. Which we don't need to do from here. We just copy this. Oh yeah, so this should be okay. And even the texture Vulkan, I don't think that creates a resource for this. Like it should just use initialize image content. Where's the staging? Staging. Right. Create Vulkan staging buffer, which does all of this. Create buffer. Do we use the staging buffer allocation for this? How does this even work? So we allocate. Okay. Oh, I see. Alright. We just allocate the buffer as is, and then we. Right. We just write to it. Okay. Alright. Got it. Okay. So that doesn't need to happen here, or maybe it does. So generally, we could leave this function here, and yeah, just have that. Yeah, you know what? I'm gonna leave it. I'm going to leave it. I think it should be fine. Format properties, expected the resource count. Again, this should be Z count texture utilities get. Okay, so this should be, and then description for, right, so we don't even need to specify the alignment. Yeah, this doesn't even need to be there. So that way we get the actual read range, and I'm actually going to store this in so this would be here, and then we'll just replace that with this. And then on map, we'll also have this sort of thing here. And yeah, that should be it. Again, the right range is this should be all right ranges. So that way we just pass that in. And then we have the memory here, right range, view checks, slice, sub-resource index. Get that. And then obviously we want uint 8 for this. And voila, I think we are finally done with this. I mean, we'll probably clean it up later in places where it's still not yet 100%. But right now, it's perfect. And yeah, it's cleaned up now. And there should be no more compile issues. So we can now get rid of, what is this? Okay, so I suppose we can still keep that. Okay. Yeah, I mean, I guess we will keep it. And this is a succeed or return. And then we can get rid of that from there, and we can also delete this. Perfect. Clean now. And we actually do have shorter lines of code. Like this is about 461. For Vulkan, we ended up having nearly 1,000 lines of code for texture implementation. But anyway, now that the texture is perfectly cleaned up now compared to what it was before, I'm just gonna compile and see if we have any issues, and we do. What is this? This is an unused variable. Is it? Oh, okay, uint 32 from uint 64. Wait, hold on a second. What does this take? Is this yeah, this okay. Alright. Yeah, that should be fine then. There we go. And then we can run it and see what happens. Oh my god. Okay, what is this? Old state is invalid for texture off screen texture. And what is the old state? It didn't even tell us what the old state was. Which we can probably log it here, and we'll do so for this one. So index, and then the arg enum. This would be would this be the previous state? I mean, I'm not sure, but we seem to be checking previous state, so I will just go with previous state. And then for this one, I will go with the new state, which we can see here. Right. Okay, so this should be barrier, new state. And then we can now see what the previous and the new states are. That is causing us grief here. Okay, it says undefined, render target, shader resource. I don't see why it should be adding undefined to the state. That should not be happening. The only time we set an undefined resource state is when dealing with path buffers. Nothing else should be undefined. Wait a second. Right, is it this that's the culprit? This might be the culprit. So, let's see. Undefined. Ah, I see. Oh, I didn't mean this. What I meant was unknown. And we can check this with the Vulkan type conversions. Get, and this will be from find flags. Yeah. Even this should not be undefined. Yeah, this should be unknown. Yeah. Yeah, it should not be undefined there. Well, how come we never had that issue from Vulkan? Probably because we don't use that flag. And let's take a look. Render target and shader resource is invalid for texture, off-screen texture, for the barriers. What? Oh, render target cannot be combined with any other state. What? So how come we never had this issue with Vulkan is the thing. So render target should be its own thing. I'm not sure where the whole shader resource thing came from actually. Like okay, I meant to say procedural. Yeah, so this procedural triangle, let's see. So when we set initial state to render target. Oh, right. I think yeah, this should this does swap chain usage, the bind flags. But the thing is, it's saying render target cannot be combined with any other state. Let's just see here. This is graphics, utility, swap chain usage, the bind flags, and I think we do use this in actuality. Just gonna see here if I can find its usage. This is in swap chain, DirectX 12, swap chain Vulkan. So okay, it's generally in use. And this is it right here. Okay, so this works. And then when we go to the actual, okay, so texture Vulkan, native object. If we have a native object, then we actually set the stage to undefined. So does that mean that for this we don't use the, because right now I think we're just giving it so right here, instead of doing this, we set this to undefined, is what I'm understanding. It's still saying render target and shader resource. And in texture, in the Vulkan texture, we don't even use from bind flags. Like we set specific resource states. Right, so yeah, we can't just blindly sign it from that, I guess. We'd need to set actual resource states. Yeah, so what we'll do is for this, it would just be what? Where's the boolean that we have? Oh, this is Vulkan. Oh, no, we don't want to change that. Undo, whatever that is. Undo that. Let's go back to with all the states undefined in this Vulkan thing, or what is going on over here? Oh, right. Okay. So, okay. All right. So in texture, what we would want to do is we would so where did we set the resource state here? So this would remain undefined, and then this one would follow the same suit. If has initial data. Oh right, instead of this, because this is bad, it would be B has initial data. This would be copy destination. Otherwise, it would be undefined. And I'm guessing that that would be what we'll do for this one as well. Yeah, so I think that would be the same for this one as well. Right, and that makes sense, I'd say. And that way, if we run it, we shouldn't run into those issues with an incorrect. Begin debug group has an issue. Okay, well, you know what? At least the textures don't crash anymore. So what we'll do is we'll just swiftly commit this as a complete refactor of the texture implementation. And actually we will and in here. Okay, so we've committed that now, and we can proceed with the rest of the fixes. And right now, the current fix that we're trying to get is why insert what? Is it insert debug label? Why are we inserting debug label? I think it's begin. It's probably begin debug group used by agnostic tools. Developers should use pick begin event. It's a diagnostic API used by debugging tools for D3D. So does that mean that we don't call begin event manually, or what exactly is the problem here? Not immediately obvious, but I think we would likely need to have some sort of pick begin event or end event or whatever. Let me just double check what that would look like in our case. Okay, well, it appears that it's legit that we can't use this unless we have pick, I guess. We have to use the pick runtime and pick runtime. Ugh, it looks like it's gonna be a hassle to have it in anyway. Yeah, it looks like it's gonna be a hassle to enable pick. Yeah, we need the pick DLL for this, so I'm not gonna bother. What I'm gonna do, oh no, we don't have this implemented. Oh no. Oh no. Okay, well, we will figure out what to do with that later. It looks like we will not have proper synchronization with fences. This is pretty bad news. But anyway, let's see, begin. What I'm gonna do is just comment this out for now, I guess. We don't even need to check this anymore. And in fact, I'd argue that we'd actually need to remove all of that. So color and name will just need to go because this needs to call into pick, which we don't have implemented right now, and it's probably going to be a hassle to actually implement it. So get rid of that, and yeah, it is what it is, but yeah, okay. A little unfortunate, but yeah. And if we didn't even have to use the render graph at all, if this worked, that would be fantastic. Uh, yeah. Uh, copy texture region failed because resource state is render target. Sub resource 0 is invalid for use as a source resource. It should be copy source. Alright. Whose path is this? But we do read the texture as a copy source. So something happened somewhere that this is not giving us the proper off-screen texture to do what we need to do. Which is pretty bad. Yeah, it might not be transitioning the resource states as needed. What? Oh no. Oh no. Oh no. Oh no. Oh no. Oh no. Well, that is particularly bad. This is not what we need. Um, that is definitely not what we are seeking. So, and I'm actually gonna take a short break now, and I'll probably be back in a moment. Alright, I'm back. Okay, well, like I was saying, this is not great at all because this does not perform the transition. This is not correct. This is bad. Right? So this is not what we need for this sort of thing. Yeah. This is bad. Bad, bad, bad. This is not it. What is this even? This is what we want. So, hold on a second. Hold on. What we want is this. So why is this not inside of so this generally should be inside of this transition thing here. So this I'm just gonna put that here for now, whatever. So this should be generally in here, and we have an array of these, and yeah. Okay, so and by the way, command list Vulkan trans is it transition resource? I wanted the implementation. Yeah, so we just go through and then do all of that. Yeah, you know what? We don't even need to do this. But if 0 and if, because I just want to paste this in here. Because we need to issue a barrier, a source. So we will need a return. So we'll need a resource barrier, and then barriers dot set. Do we want to initialize it, or do we just want to? Because we just need a count here, and we get that from the and then this would be and then we would only do this if barrier flag is that. Come on, we're still in debug. That's why. Okay. And if it's update state is when we would update the actual resource. Other than that, we should just be set for this, and then yeah, so previous state, current state, previous state. Yeah, so we're not expanding and getting ref, we just retrieve the actual, and we will need to change how this works. So this would be that, and then once we have the barrier, we can literally just copy this over and just change this to D3D12 barrier, and this would be P resource P, and this would be I guess we can do that, and then obviously this becomes barrier, yeah, resource, resource down, and then obviously we'll need to dynamic cast this. And yeah, we would wait a second. Yeah, we do need right. So we would need one for the buffer and then one for the texture. And where's the command list for Vulkan? Right here. Okay, so we'll just say if we can get a D3D12 resource from here, then obviously we would be able to proceed. So this would be auto the texture D3D12. If this was the case, Else if, yeah. All right, so if we're able to get that, and then this should be where'd the resource go? Huh? Oh, right, transition resource. Okay. P resource would be that, and then that would be that, and then similarly for this one we would have transition resource, and then that would be that, and the resource before would be the same thing. It would be if you know what? It would be if auto and that should be not the texture. Oh, okay. Well, whatever. P P previous texture. D3, D12. The dynamic cast, and then we will dynamic cast this one, and then this would be barrier resource, and that way we now have access to the old resource. So if we can do this, then this would be D3, D12 barrier transition date before. Where's the before resource coming from then? Let's see. And perhaps this song is not it, so we'll just simply skip it and go to something a little bit more interesting. Okay, so well, now that we're a little bit more jovial, we can continue with our plan. So Let's see. Well, yeah, I mean, I guess there's no. Okay. I thought we didn't have this. Where did this come from? So we have the resource barrier that has the type, flags, and then the transition. So this is the one that we are filling up. We have the resource, sub-resource, and the state before, and then the state after. Okay, so you know what? Yeah, looks like this is not even necessary. So I'm gonna just previous state. Where did that come from? Is that from the barrier? Old state. And then we can use the D3D12 type conversions, get resource state. And then same thing for this one. And that will be the new state. Yeah, we'll just go with all the sub resources for now. I mean, we could potentially calculate it from here, but right now we're not. Actually, you know what? We can actually do it. Like if we type yeah. This would be the MIP slice, and then barrier, array slice, barrier, MIP level count. So we could potentially do that for the sub-resource index. And I'm not sure why we would have I mean, we could potentially do that, but yeah, nah, we're just for simplicity gonna transition all the sub resources, cause yeah, we're keeping it simple over here. Cause it has like a number of sub resources, not just one of them, right? So, and if you're transitioning it, you would likely want to transition the entire sub resource anyway. So there we go. That's it for that. And but the thing is, I think we can We can potentially use, is there something called, because we had this thing in D3D11. Yeah, I'm not seeing it here for calculate sub-resources. Which we can potentially implement. And this would be MIP slice, array slice, plane, plane size, and then the number of MIP levels. Oh, this should be slice actually. And then the number of MIP levels and the number of array slices, I suppose, or array slice. MIP slice, array slice, plane slice, MIP level count, and array size, I guess. Okay. And we're going to implement this. I'll put that here, and then that with that, and then we will return. Oh, I guess it already knows. Is this correct? MIP slice plus array slice times MIP levels times plane slice times. Yeah, this is correct. Okay. Alright. So we can generally calculate what sub-resource that this stuff is going to go into. So it's not usually out of the ordinary for us to do that. We will, I guess, potentially refine this to handle some of the other cases that are currently missing. But now that we have a way to calculate what sub-resource, I guess we can integrate that into this. But right now we don't actually clear or we don't transition a specific sub-resource, so it should hold up this way at least for this little while before we get that sort of thing implemented. So I guess I can just do this part and then call it a day. Well, let's check it out, see if it actually works. Oh, right, and also, we're not even transitioning this thing yet, so this, at the end of this, we should have D312 command list, transition, resource barrier, and this would be barrier, get count, and then barrier, get data. There we go, and let's see what happens. also we had a bit of an error here initially. Right, only supported for pod types, so we need to move this into our precompiled header as a pod type. So, and then if we run that now, see what we get. Okay, alright, even more errors. Let's see. And the terminal is actually blocking my, okay, there we go. So what are we looking at? What is the error? Resource barrier. Before state, copy destination, a source specified by index 0 does not match the state rendered target specified. What is this? Off-screen texture specified in the preceding resource barrier or as initial state. What? So yeah, it was indeed transitioning the resource state. It's just that we were not doing the proper transition. Like it was just a naive. Okay, anyway, so let's see. We have transition here, none, and there's the resource, copy destination, state before, copy destination, state after, copy source. But apparently it's in render target, which doesn't sound right. We should not have it in render target because, well, first of all, we create it here, and then we have it as copy destination because we need to initialize the texture. Is that even correct? Because this should initialize it as copy destination, but sub-resource 0 specified by the transition barrier does not match with the state render target specified in the preceding resource barrier or as initial state. So it looks like the initial state is wrong somewhere. And let's take a look. We're in the transition branch though, right? So resource barrier flag none. What type of flags are we expecting? Oh, wait. Okay. Okay, so here's the thing with the render graph currently. Okay, so with the render graph, actually, what we can do is we can enable split barriers. And split barriers, and we can try it and see what happens. And then we'll go back here, and instead of doing this, we will check if barrier dot flag is set. We go and what? Where is this? Is this in a begin or in an end? I actually old state, new state, transition type. Okay. Begin, then oh wait, hold up. It looks like it had it. It had it. And then oh, whoa, what did we do here? Anyway, so if it's a begin, then we make it begin only. Are these flags? Okay, they're flags. Okay, so okay. Yeah, so we can do this sort of thing. And let's see if it actually helps. Because there's this thing that DirectX 12 can issue split barriers. And let's see if it actually did one. Wait, what? What is this? Transition or verify restore state for ray tracing. Oh, it worked! Okay, so that works. So using split barriers work. Interesting. Okay, so that is good to know. So this worked. So we should actually, what is this? Resource barrier flags. Okay. Well, you know what? Whatever. We will not have it in here. We will have it in here instead. So we start with. Actually, this will become an equal. And if it begin, then we begin. If it's else, actually, you know what? Else if here, if area dot transition type begin or none or immediate, then we set this and else there we go. So this works with the split barrier, but then it adds an error. Off-screen texture, like why is it calling this ray tracing thing? Transition resource, is it transition or verify? Resource state for ray tracing, and that was in set shading rate, which we don't call, by the way. And this is not correct. Find subpath attachment. We should not be calling this function in there anyway. And we can probably do some commits. Oh, right here in clear render target. Oh my god. No, 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 no. No, no, no. This should not be called there. And we got an error, and it's probably that the states are not correct. Clear render target. Yeah, resource state, copy destination, resource off-screen texture is invalid for use as a render target. Okay. Copy destination. Shouldn't it have set a proper state? And let's see. For the clear, why? Setup off-screen path. Wait a second. The clear texture. Well, let's see if this works. If we actually read the texture as a render target. Okay, now we're back to this. Yes, 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 yes. Okay, so this should read this as copy destination. Read texture. I think this should read that, I guess. As copy destination, and then what does this even read texture? Is this not correct? Oh, right. I'm just gonna do that. So this should be that, and then this should be copy destination, and then we will write texture, and this can happen with just the handle. So this would be data off-screen texture, and then this would be render target. I think that can work. especially with the whole split barrier thing. Can I not read texture because it was not deployed? What is this? Oh, it's the off-screen path. Okay. 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 Right. Texture. And then texture description. And then we would need to, I mean, hopefully it, and only barrier is called without any begin barrier in it. Yeah, so this is the problem here. So because textures are defined or are created with a specific state, we have issues where where things like this become problems. This is a problem. So we can try leaving this as is, and then right over here, transitioning so transition and then transition dot old state dot old resource is contact transition old state is copy destination, new state is render target, and I think that's, and then transition dot type is immediate, transition dot mip level, transition flags. What type of transition? Yeah, update states as well. And then we just call commands. I just want to see this work. Make array pointer, and then this would be transition 1. So, I mean, if we can make this work, that would be good. Because, yeah, okay. Well, let's see what happens, because, well, it looks like we have 2. Is this correct? Begin and none. And somehow we have 2 transition states. And what is this? Before state, common or present a resource off-screen texture specified by barrier does not match with the state. Render target as initial state. Oh my god, this is very annoying. Very inconvenient. Very, very inconvenient. Okay, alright. Okay, well, you know what? Let me turn off that split barrier sort of thing, because it's obviously causing grief. And I can just do that by discarding this change. Well, let's see what happens. And Well, let's see. Incompatible resource type. Before state copy destination. Does not match with render target. Okay, alright. Well, let's take a look, see what it is. Transition copy destination before is copy dest, but it's you know what? I think I think I think let's go down here for a bit. So this actually transitioned it, but now it's saying, is it complaining here or is it complaining in the other? It's saying does not match with the state. Copy dash is does not match with the state when the target. Oh my god. Could I just continue without even caring what happened? Present resource. Oh my god. Okay. 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 Oh, it worked. Oh, okay. So you know what? What I'm gonna do is I'm going to disable debug. Let's see what happens. Stop that. And yeah, because I really just wanted to see it clear the back buffer, and that's what I really need before I can end the stream. So that's what I want to see. Doesn't matter if it is we'll fix the issues and the edge cases later. And where's the device? Right here. We'll just disable validation and see what happens. Yes, it works. It works. It works. It works. Now, again, there are still issues with there's still issues with the transitions and stuff that we still need to resolve for both Vulkan and DirectX. Now, let me resize and see if it fixes if it crashes. Oh, one more thing is, oh, it will crash because we don't reset the resize buffer. Yeah, 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 yeah. There it is. Yeah, this should be back at 0. And you'll see, so some call was incorrect. I don't know what call was incorrect, but anyway, I was thinking that it was the resize that we don't, or we can update swap chain and, hold on. Yeah, update swap chain, create the XGI swap chain, and, so after we create the swap chain here, I think we should be setting this should be 0. because we don't set this anywhere else apart from over there. Right, so there we go. So hopefully that fixes that portion of things. And obviously we need to fix the transitions as well. I think I will enable split areas by default actually. And I'll just need to make sure that it's fixed. And I noticed that it's actually using a tad bit less memory than our Vulkan implementation does, which uses less memory. Anyway, let's see what happens when we resize the back buffer. Oh, it crashed again? Okay, alright, okay, alright, alright, alright. Alright. So there's something that needs to be done there. Yeah, you know, we'll fix that later. But you know what? What I'm gonna do is I'm just going to create a bigger display so that we don't have to deal with this. So this would be, gonna comment this out. And then this would be 1920 by 1080. And I should probably enable center on display. Window true. I think it's true by default. Yeah, okay, never mind. We don't need to set that. Yeah, I just wanted a bigger display to see. There we go. Okay, so we got the goal for today more or less accomplished. We were able to take our rudimentary texture implementation and then refine that a whole bunch to be able to get something displaying on the screen. And even though we're technically not drawing anything, we're just setting a specific color, it's still better than what we had initially where nothing was working. Now, I guess the future work or the future immediate work is to fix the texture or just generally fix resource state transitions because those are broken right now and those need fixed. Now we got to fix the resource transitions, and then we've also got to fix or implement other things as well, but some of those might just be behind the scenes. But I'll just leave you guys with a bit of a just clear display screen or whatever, and you know, this is just dynamically changing colors based on time, and I'm just gonna let it cycle until it gets back to orange, and then we can possibly, and then I'll have to end the stream and see you guys at some point later in the future. So enjoy.